Hi all. Today we're going to look at the different points of concurrency that we can create through construction. So recall that we have made a construction that involves one point already. We've talked about a circumscribed circle, which is just a circle that's around a triangle, which that has each of the three vertices lying on the circle. And that's best represented by choice 2. The center of a circumscribed circle is referred to as the circumcenter. So we can remember how those two would stay together, circumscribe, circumcenter. And it's formed by perpendicular bisectors. So remember, for this construction, we took the perpendicular bisector of two of the sides of the triangle, and we found the point where they intersected. That was our circumcenter. You could do all three sides, but once you have the two, we already have enough. Okay? If the triangle is acute, meaning all the angles are less than 90 degrees, that circumcenter will lie inside the triangle. If it's an obtuse triangle, it will lie outside the triangle. And if it's a right triangle, it will lie on the triangle. That would be true for any type of circumcenter. Since we've already dealt with that construction, we're going to go on to a different type of construction that kind of has the same kind of pieces. For every triangle, there is also a unique circle that lies inside the triangle. And it lies inscribed, or it's called an incircle, in such a way that it will only touch the sides of the triangle once. And that's something that's referred to as being tangent. It's represented best by choice 3. If you look, the circle's completely inside, where in the other options, like 1 and 4, it's half inside, not all the way, and 2, it's completely around the triangle. But so in 3, it's completely inside, and it touches once on each side, so it has 3 different tangent points. We're going to try to construct one of these. So to find the center of an inscribed circle, it's referred to as the incenter, which we actually found an incenter already in class. We did it by using the construction of angle bisectors. So what we're going to do first is construct the angle bisector of angle A and angle B. We could use C. There's no real reason for picking A and B, just for except the way it might fit on our page nicer. But the reason we're doing A and B is just because we have to pick 2 out of the 3. And then we're going to label that intersection point as M. And then we'll come back. So I'm going to go to a separate page so I can do my construction. We have here ABC. So my triangle is a little bit different than yours, but it should get the basics of our ideas down. So first thing we're going to do is take the angle bisector of A. So I'm going to pick up my point, and I'm going to draw a construction that intersects both lines that make that angle. Once I do that, I'm going to go in and I'm going to use those intersection points that we just created. And I can change the length if I want to. I don't have to keep it the same. I can if I choose to, but I'm going to make an arc from each of the endpoints. So notice we have a nice clear intersection point. Oop, lost my arc. Hold that thought 1 second. Oh no, what am I doing? So to take that angle bisector, remember we start at A and we're going to make an arc. That way it intersects the angle at both sides. So both sides that form that angle are shown. And now we use those intersection points. We can change the length if we so wanted to. Oops. So by taking that, we're at A now. We're going to change the length of our compass. Remember, our goal is to get an intersection of both endpoints. So we have that first intersection. We're going to go back to either intersection now. And if you want to change the length, you can. You don't have to if you are comfortable with the length that we have right now. But we're going to make an arc from each intersection now without changing that length. So we have one final step. We take our line from A through that intersection. That's the angle bisector of A. We're going to do exactly the same idea, but this time we're going to do it from angle B. So we want to start with an arc that passes or starts at B and goes through both sides. We make an intersection point here. We can make, if we want to stretch out further, we can, just so we can avoid interlocking with the pieces we already have. But I'm going to make an arc from the first endpoint, and then again from the second. And we determine exactly where those two are going to intersect. So from B, we're going to draw through right about there. Now, remember we were going to label our intersection as point M. So I'm just going to make it a little thicker so we can see exactly where our point is. That's point M. So from point M, the next part, so we're done with part A, our next part is to make a perpendicular line from M through AB. So recall how that's going to take place. We start at M. We want to go towards the line AB. We want to get perpendicular. So we're going to make an arc that passes through AB twice. Once we have that spot, we can either stretch out further or we can leave it alone. We're going to make an arc from that intersection and from the other intersection that's formed as well. Now we would just need to draw a straight line from M through our intersection, and it should form a perpendicular line. We're going to label that intersection point as D. What you need to know is that that line M to D is the shortest distance to the triangle. Okay, so from the center point, the shortest distance to any line from a point is a perpendicular path, because you want a straight line, and that's going to cut out any extra pieces. From there, that shortest distance, recall, we only want to touch our circle or our triangle once when we build the circle. So since we only want to touch once, we're going to finish this off by starting at M. And we're going to change the size of our compass. So we stretch to that point D. And when we draw, I should get a circle. Oops. That would make an in-center. Now mine's slightly off because of the clicks that were locked into place by this program. So I am a little bit outside here, but same thing. The Regents does allow for human error. So if you made all your constructions and you showed all your markings, like the grader could clearly tell you had an angle bisector and a second angle bisector, a perpendicular line and a circle, you'd be perfect. So to construct an in-center, it's a little more than the last one. We first construct the two angle bisectors, so one from A and one from B. We're going to construct a perpendicular line from that in-center point down, and then that's your radius. MD would have been the radius of the circle. So let's go fill out the rest of our sheet and see where we left off. Oops. So we have our construction. Explain why M must be equidistant from all three sides of the triangle. Well, we should have filled that in. We should recognize that we've just constructed three angle bisectors. So when we're constructing angle bisectors, like we said in that angle bisector lesson, the angle bisector is equidistant from the two rays that form the angle bisector. So why must M be equidistant from all three sides? It is made from angle bisectors which are equidistant from the rays that form the angle. Okay. So we followed through our construction. We finished that off. Let's look at the next one. So exercise 3 is the same thing. Pick two angles, construct the angle bisector of them. Then the two that you did pick, use that third point, that in-center point that we've just created to the side that has your two angles on it. So if you pick EF, you would use the side EF to find a perpendicular line. So use the video and try to construct that. Once you've constructed, you should notice that in numbers 2 and 3, the last exercise in this one, the in-center still lies inside the triangle and inside the circle. No matter what, that in-center has to be inside the circle and it has to be inside the triangle. It's not like our previous circumcenter that could have been outside and inside. In-centers, no matter what, it's inside, just like in the name. There are two other types that we are going to talk about. We are going to construct these, but there are no circles that are attached to them. But what we need to know is that there is a centroid and an orthocenter out there. A centroid is formed by three medians. Now remember, a median is when you construct the midpoint from a perpendicular bisector, and then you find its midpoint and connect the one vertice to that midpoint. So it is a little bit more. You have to do a whole median construction, so you do the median twice. So we're doing two perpendicular bisectors and two lines connecting. So we'll practice that more in class. Similar, we have an orthocenter, which is created by altitudes, which is two perpendicular lines. Like I said, we will practice that more further. But the last thing we're going to do is just fill in this table. We do need this table, and we do need to know the keywords that go together. So altitudes form orthocenters. Medians form a centroid. Angle bisectors form incenters. And perpendicular bisectors form circumcenters. And there is a fun way we can remember this. So see how we have A and O, M and C, A, B, I, P, B, C. One phrase that you can keep in mind is that all of my children all bring in peanut butter cookies. Now I know we